Hello, everyone, and welcome to Streamlining Provisioning with HCP Terraform and ServiceNow. We are incredibly happy and honored to be here today to share with you the findings of our product.
To give a little background about who we are, my name is Pratima Khunte. I am a cloud platform engineer at Skechers with 5 years of experience, primarily in software development and infrastructure as code.
And my name is Ramon, Borunda, Senior Cloud Platform Engineer at Skechers USA with 25 years of experience, and I do specialize in multi-cloud implementation and infrastructure as code. Before we speak about the true magic of integrating HCP Terraform with ServiceNow, we want to talk about our problem statement. We want to share our story and the pain points that led us to find a better way of doing things. Going down the list of challenges, the first one is we had a lack of requirements gathering. We used a simple, open-ended ServiceNow form with very little direction and guidance to our stakeholders. This created a very particular set of problems. On the one end, we had individuals that simply entered the following in the form: I need additional EC2 instances. Now, I want you to think about that and try to develop a procedure to fulfill that requirement. On the other side of the spectrum, we had end users that gave us a significant amount of information. They would write tickets like the following: we need 4 EC2 instances in this particular AWS account in this region, on this VPC across these subnets, and by the way, they should be of a certain type and run this operating system. And while we appreciated the amount of details, there were certain gaps in what they were telling us. For example, what about security groups? What about potential IAM roles? What about backups and maintenance windows? All this led to a lot of back and forth with our end users for us to truly understand the requirements they had. Another challenge was a lack of consistency, not just on the requirements gathering perspective, but on how we approach building the resources and how we deployed them. We gave our engineers the liberty to decide how to best approach delivering what they needed to do. And at the same time, we gave them the liberty to decide how to deploy those resources. This led to the fact that we had a significant amount of snowflakes across all our platforms, even between resources of the same type. When it came to deployment, some engineers would use CLI, while others will use some kind of infrastructure as code, like Terraform, CloudFormation templates, or Azure Resource Manager. Others would use good old ClickOps, and yet others would use some type of CDK, like with Python. All this led to an extremely high lead time between going back and forth to understand their technical requirements and their business needs, and us reinventing the wheel every time we had to create a particular set of resources. In addition to that, we had a problem with priority. We have to balance existing projects with new projects and run the business tasks. A major challenge we had was the fact that we had no cost forecasting. We had absolutely no FinOps culture or methods in our process. This meant that we had 2 big problems to address. The first one was that our stakeholders would come back to us months later and ask, how come this is so expensive? Now I'm having to justify against my leadership team and explain why we're spending this amount of money to run a particular workflow. On the other hand, it made it very difficult for us to prepare our budgets. We had to continuously work with our leadership team and the finance department to make sure we had the necessary funds to pay our cloud bills. And the last challenge we had was a lack of security prevention. Now, let me be clear. Our cybersecurity team does an outstanding job at protecting us. But we realized we were not part of the solution. We were actually part of the problem. All we did was grab our code and the resources it would create and throw it over the fence so the cybersecurity team could address any potential vulnerabilities. We wanted to shift left when it came to security and allow the cybersecurity team to protect us while we were responsible for preventing any potential security issues.
Let's now dive into the previous state prior to us implementing the HCP Terraform and ServiceNow integration. Previously, the end user had to submit a generic ServiceNow ticket, which did not prompt the user for any required fields. They had just a single general text box to enter all of the required details. Then, after the ticket was submitted, it was routed to their manager for approval, and after the manager approved the ticket, the cloud team was responsible for gathering all the required additional requirements that were not captured in the initial ServiceNow form. After the cloud team was able to scope out the project and assign it a time estimate, we had to prioritize it in one of our upcoming sprints during our prioritization phase. Then, when it came time for deployment, since there was no standard method of deployment, we either used CLI, ClickOps, Terraform, CloudFormation Template or Azure Resource Manager, or Python to deploy the resources. Finally, after the resources were deployed, it went back to the stakeholder for validation, after which the process was considered complete.
Now, this workflow represents our new happy path way of doing things. Every single box in green represents a new procedure we introduce into our workflow. Starting on your far left, we now use custom ServiceNow forms that are specific for the resources being requested. They're highly targeted and have questions that will give us enough information to not only create the resources, but to fully automate this process. We continue to ask for manager approval because we want to make sure that the right hand knows what the left hand is doing. If they are unable to secure manager approval, the ticket automatically closes and no one is the wiser. However, if they receive approval, for the first time ever, the ticket comes to the cloud platform team for review and approval. We make sure that the requirements match our architectural guidelines and standards set forth by our Cloud Center of Excellence. If for whatever reason we don't believe the ticket is up to par, we will close the ticket and automatically notify the end user. This particular flow has been a huge success with our end users. They appreciate the fact that they're kept in the loop rather than being in quote-unquote an in-progress limbo with no real traction behind their tickets. If we approve the ticket, we pass on the work to HCP Terraform and allow it to do what it does best. It will run its standard workflow phases like Terraform init and plan to ensure everything makes sense from a Terraform perspective. After that, it goes into a post-plan phase where we add additional third-party software in a couple of run tasks. The first one is infra cost, which is able to look at the code, identify the resources that are going to be created, and give us a cost approximation. The second run task is sneak, which basically goes through our code to determine whether or not it's secure enough for us to deploy. If for whatever reason, either infra cost or sneak considers the code to not be within parameters, the ticket will close and no resources will be created. If both InfraCost and Sneak provide a green light, Terraform will run an apply command and create the necessary resources against the appropriate AWS accounts. In the next slide, we're going to show you a system diagram of how everything works together. But everything starts with the customer going to a ServiceNow custom form to enter the necessary information.
The first component of our architecture diagram is GitHub. GitHub is our code storage repository in which holds all of our code for our Terraform modules. Each module is in its own repository with a three-part naming convention: Terraform-provider name, -resource or repository name. And each of these repositories are published in our enterprise organization. The next component, and one of the major components of this integration, is ServiceNow. This is where the end user submits their tickets, and this is where the service catalog is configured. The existing Terraform plugin comes with built-in catalog items, and our ServiceNow administrators were able to make a copy of each of those items and customize them to gather our required inputs that are required for our Terraform modules. They also went in and were able to configure the variable set and the Terraform AWS credentials that are required to be passed into HCP Terraform that allows HCP Terraform to deploy into a specific AWS account. After the ticket is submitted, a new workspace is created in a given project, which is where we can see the Terraform plan and apply information.
As you can see, HCP Terraform is at the heart of our new architecture. Not only does it take inputs from ServiceNow to create a new workspace, it has additional value-added features that we're leveraging. Top of mind is state management and file locking. If you've ever had to manage back-end Terraform state files, you know it can become an administrative headache and potentially a nightmare. You're always second-guessing yourself. Did I update the correct bucket? Am I going to override somebody else's state file? Another important feature is the fact that HCP Terraform can leverage not only AWS OIDC identity providers, but the same type of providers across multiple cloud providers. We make use of HCP Terraform private registry to publish our own modules so they're only available to our organization. Another important thing, and we'll talk a little bit more about it, are the run tasks. As we mentioned, we integrate with Snyk and InfraCost. Snyk is an infrastructure as code security software that can understand the resources that are going to be created by Terraform, but most importantly, understands the configuration and any potential security vulnerabilities that may be present. It allows us to be secure from the start because not only does it integrate with HCP Terraform, it integrates with all major IDEs, so we get real-time feedback on the code that we're writing. And a really important element in Snyk is that it can give us a priority score on any potential vulnerabilities. It will categorize them as critical, high, medium, and low priority. On the other side, we have InfraCost, which allows us to shift left into a FinOps mentality. It gives us a really accurate forecasting of the cost, and it has additional guardrails to ensure that we're following FinOps best practices. And finally, the last element is going to be our AWS accounts. HCP Terraform uses a secure authentication method based on STS tokens, which allows it to assume a specific role with the necessary permissions to create and destroy resources.
As we saw, there were multiple components that come into play with the integration. We will now move on to 2 demos that demonstrate how all of the components work together for this integration.
Hi everyone, this is the demo for the simple workflow to provision a S3 bucket in an AWS account using ServiceNow's Terraform catalog. As a prerequisite, before we can start using ServiceNow, our module must be published in our private registry within HCP Terraform. In this case, I have published the S3 create module in our private registry, which will be used for the remainder of this demo. As you can see here, there are a predefined set of required inputs and optional inputs, which we will take as input from our customized ServiceNow form. Now, we will start taking a look at the catalog item, which will take in all the inputs required to provision that S3 bucket. As we can see here at the top, this is a copy of the provision no-code workspace and deploy resources flow. The provision no-code workspace and deploy resources flow is a built-in catalog item that comes with the Terraform catalog plugin in ServiceNow. Our ServiceNow administrators were then able to make a copy of the existing built-in catalog item and customize it to include the inputs that we need from our form. The first field that is required by our catalog item is the workspace name. This field is optional and if the field is left blank, it will create a workspace in HCP Terraform with the ServiceNow ticket request number. The next field in our catalog item is this no-code module name. In this case, this has been hard-coded to say S3 create, which exactly matches the name that we saw in our private registry. The third field in our catalog item is the Terraform project name. This has also been hard-coded in this case, which is where all of the new workspaces will be created. The next three fields, which are the name of the bucket, the region, and the account, are all inputs that we require from the end user. For the sake of time, I'm going to go ahead and pre-populate these fields. I have set the name of the bucket to be ServiceNow Demo Test Final, the region to be US West 2, and I've set the account to be the account where I want this bucket deployed. After I selected the account, these two Terraform variables were populated. In the variable set configuration, this Playground Infra account is mapped to the required environment variables that are given to HCP Terraform in order to configure HCP Terraform to authenticate with AWS using dynamic credentials. In this case, as you can see, we have passed in the role ARN, which has the permissions to deploy into this specified account. Now, I will go ahead and submit the ticket. In a production environment, we would want this ticket to go through all of the necessary approvals before any resource is deployed. However, because this is a POC environment, we are able to submit our request without any approvals, and we can track its status within HCP Terraform. I'll now switch over to HCP Terraform so we can see the Terraform plan and the Terraform apply. As we can see here, our new workspace was created with the ticket number from our ServiceNow request. This was triggered via a no-code provision, and it went through a Terraform plan, which shows that it would create a new S3 bucket with the name that we specified in the ServiceNow form. After the plan finished, it also went through two post-plan tasks, which are from InfraCost and Sneak. After the Terraform plan and the post-plan tasks succeeded, it went through a Terraform apply and actually deployed the AWS S3 bucket with the given name that we specified in the ServiceNow form. Let's now switch over to that AWS account to confirm that the bucket was actually created. We can see here in the AWS S3 console that the ServiceNow Demo Test Final bucket was created in US West 2. And that's all I had for the demo. I hope you all enjoyed. Thank you very much for your time.
For our second demo, we're going to go through the creation of a new VPC.
Hello, everyone, and welcome to this demo. Using our custom HCP Terraform and ServiceNow integration, we will create a new AWS VPC. The key elements of this demo are the Terraform catalog item, the AWS resources created, and how SNCC and InfraCost can add value. As you can see, our custom VPC catalog item, named VPC Create, has fields specific to the resources created by our HCP Terraform private registry module. The custom fields are VPC name and VPC CIDR. For the sake of time, I have pre-populated these fields with the appropriate values. But before we order the VPC, let's take a quick look at our demo AWS account to make sure there is no VPC-related infrastructure present. We will start by taking a look at VPC-related features. As you can see, there are no VPCs present. There are no subnets present, route tables, internet gateways, NAT gateways, or security groups. We can now go ahead and order our new VPC just like any regular stakeholder would. From this window, we can click into the request number for additional details. The most important item in this page is the fact that a new Terraform workspace was created with the ticket number for the requested item. We can now go into HCP Terraform to track our progress. As you can see, HCP Terraform encountered an error when it tried to run the code from our private module. Let's open the workspace to get additional details. After we open the runs page for this workspace, we can see the problem is not in the code itself because the Terraform plan succeeded. However, we also see the failure came from the post-plan phase when Snyk found a security vulnerability that needs to be addressed. Once we look at Snyk's report, we come to realize we left quad 0 open for all ports in our security group. This, of course, is an insecure configuration, but it's important to note that Snyk prevented us from deploying this insecure infrastructure. I'll go ahead and correct the code offline and reorder the VPC. Now that we have corrected the code, we'll go ahead and order the VPC again and go back to HCP Terraform to track the progress. After giving HCP Terraform enough time to complete this workspace, we come to notice that the application and creation of 29 resources in our AWS demo account were successful. We no longer see the problem with Snyk because the code was corrected. We do want to talk about the information and the value added from infra cost. Not only does it give us a projected cost of the new resources, it also has additional guardrails for compliance with FinOps best practices. Now that the HCP Terraform run has completed, let's take a look at the AWS demo account to make sure all resources got created. As you can see, the HashiCorp demo VPC got created with the CIDR range provided in the ServiceNow form. The same goes for subnets, where we have public, private data and endpoint subnets. We have new route tables, one for public and one for private with associated subnets. We have an internet gateway. We also have a NAT gateway. And finally, we have a series of security groups with the appropriate security group rules. This concludes the demo. Thank you for your time.
At the beginning of the presentation, we mentioned 5 business challenges we were facing prior to this implementation. To recap, the challenges include requirements gathering, consistency, high lead time, no cost forecasting, and lack of security prevention. Let's now bring this full circle and list out how we solved each of those business challenges. To solve the requirements gathering challenge, we created the custom ServiceNow input forms, which allowed us to gather all the required inputs prior to deployment and eliminated the back and forth between the engineering team and stakeholders. We started publishing more modules to our private registry, which allowed for code reusability, abstraction, and scalability. This also allowed us to use these modules as no-code modules for this specific use case. We created a self-service model with appropriate guardrails. Before, the cloud team had to prioritize a task in their upcoming sprints, but with this new implementation, stakeholders are able to get their resources within 24 hours given they've gotten all of their approvals. With cost modeling with InfraCost, we're able to predict the cost of deployment, and we're also able to incorporate FinOps best practices into our workflow. Finally, we incorporated infrastructure as code security scanning with Snyk. This allows us to detect any risks and vulnerabilities in our code prior to deployment. Throughout this implementation, we learned several lessons on both the ServiceNow side and the HCP Terraform side. To start off, we learned the difference between encrypted and unencrypted text values in ServiceNow. Text values come encrypted by default, but we learned that HCP Terraform is not able to read those encrypted values, so we had to convert them back to unencrypted variables so that HCP Terraform would be able to read them. We learned that HCP Terraform had to be licensed in order for us to complete this integration. We learned that the Terraform plugin within ServiceNow was able to be customized for our requirements. We also learned about the naming convention for HCP Terraform. We learned about the variables naming convention in ServiceNow and that they had to begin with the string tf_var. Finally, we learned that all of the Terraform configuration files in the module must be defined at the root level.
Now, before we go into our future use cases, please take a couple of moments and scan this QR code. It will take you directly to HashiCorp's documentation on how to integrate HCP Terraform and ServiceNow. Now, this is a list of potential use cases. Whether or not they get approved and prioritized is a different story, but this is the kind of thing we want to be working in the next 12 months. We want to implement a self-service Databricks cluster provisioning process. We want to mature in our use of HCP Terraform when it comes to managing IAM roles and policies. We also want to fully automate the creation and management of AWS IAM Identity Center resources. We want to integrate more HCP Terraform tests into our process. And finally, we want to integrate with additional HashiCorp products. Particularly, we want to work with HCP Vault, Radar, and additional Sentinel policies. But the most important question we have for you is the following. What can you think of? What are those pesky processes within your organization that could benefit from an integration between HCP Terraform and ServiceNow?
Before we conclude our presentation, we would like to give some shout-outs to a couple members of our Skechers ServiceNow team. Adrienne Kubarua, who is a ServiceNow administrator at Skechers, and Soham Mukherjee, who is a senior manager at Skechers of the ServiceNow team. This implementation would not have been possible without their efforts and support.
And before we conclude, please connect with us through LinkedIn. We would love to collaborate and form a community around the integration of HCP, Terraform, and ServiceNow.
Thank you very much for your time.